I'm Professor Eldred Majors, and prior to coming to RIT, I was an electrical engineer and an engineering manager over at Eastman Kodak.
I was an engineering manager, I was chief engineer of a radio company that built communications equipment for worldwide communications.
Sometimes the project was start from scratch, and you took over and started to put in a new either a new machine or a new process to solve some kind of an engineering problem. It was always started out with a problem, either something that needed to happen from a new either a new product the company was going to make, or a machine needed to be speeded up so that you could reduce the unit cost of how much it would cost to manufacture a product, or something needed to be fixed because it broke down too often. Those are the three type of things that we usually did.
I got involved in regulations, government regulations on our products and on industry. And what I learned was that often decisions are made not on a strictly technical basis, but they're made for business reasons, obviously, competitive reasons, and also because of government regulations. You have to make a decision on what you do so that you meet government regulations, even if that's not the optimum technical solution. So that in the real world there are lots of things that affect any given decision in a design. Things that aren't in the textbooks.
I think the biggest skill that students should have when they get into industry coming out of a college is the ability to be open-minded to learning new things, because you're going to be dealing with things that you haven't seen before in college. Okay, you're going to be given a bunch of tools to solve problems, and what you're going to have to do is attach these tools or implement these tools into problems that we haven't seen here. What you have to understand is that these things are going to be obeying the same laws that we studied, Ohm's Law, KVL, KCL, things like that, and that be able to be open to the fact that you can apply these laws to new situations and new problems.
Just coincidentally, it seems like everything that I now teach is what I used in industry, but of course that's cause and effect. I'm teaching what I know. Circuit design and circuit theory is a fundamental concept, and you use it even if you do your designs using computer-assisted design programs like PSpice. They tend to be analysis programs. They'll analyze something that's already designed and give you the answers, what's the output and so forth. But you have to come up with a design in the first place, and that requires an understanding of circuit theory and electronics fundamentals.
I work both individually on some projects, and in some projects I work with a team. Most of the time it was with a team, very diverse team usually. And I say diverse, I mean there's usually a team manager, a project engineer who took care of the costs and the scheduling and so forth. Then there was usually an electrical person, electrical engineer, a mechanical engineer. There were drafters involved, sometimes technicians, people who purchased things, people who shop people who built things for us, and people who helped us put together the hardware and what we used to call it debugging. Now it's called troubleshooting.
I should tell you that when I was a hiring manager in industry, I used to like hiring RIT graduates, especially electrical technology graduates, because I knew I could count on them being productive from day one, because they had co-op experience, and I knew that I didn't have to worry, as I did on EE graduates, who I would sometimes also hire. But when you hire a brand new EE graduate, you have to worry about, are they going to burn their hand on a soldering iron? Are they going to put their eye out with a wire from a diagonal cutter getting into their eye. I mean, they do stupid things because they just don't have practical experience. You know, whereas you guys will have lots and lots of practical experience.
Absolutely. There was a lot of fun on the job. Is one of the things that used to happen all the time when the job was finished. It was it was usually some kind of a party afterwards. One of the neatest things that used to happen is that if we were making a new product, we would gather around and watch the new commercial that was going to be published for the product that you worked on. That was extremely rewarding. You know, where you could see you worked on this project and you made it happen.
It's always challenging trying to make something do what it wasn't designed to do. You know, it's an intellectual challenge and it can be fun. So I remember early in my career, we wanted to watch the World Series and there were no TVs in the electronics lab. So we managed to convert an oscilloscope so that we could pick up the TV signal and watch the games on the oscilloscope. You know, and a lot of people, you know, cooperated. They brought all of their little bits and pieces that enabled us to do it.